Welcome everybody. So first of all, thank you Open Reality and Echo for asking me to do a presentation here. It's my first time, so I think I only missed one, right? So it's not that bad. They have asked me to do a session a little bit on a different subject, I think, than we saw in the rest of today, and that's about analytics and assurance and what it can mean in networking infrastructures. So that's why I built the session around, so I don't know all the nerdy Wi-Fi angles and buttons, and they will come by because I think we can automate some of them or do better analytics on it, but let's see during the presentation. So my name is Dobias van Ingen, and I am within Aruba. I'm working 19 years or so in HPE, and I've been 15 years in networking, and I do this role about 12 years, and I'm for EMEA now in the Aruba business unit. I'm CTO, and what we call SEs is our pre-sales director. So I have a lot of travel. Actually, I'm not as Stephen is so popular in, so I'm more in the Hall of Shame, I think, than in the Hall of Fame. But let me tell you the true story actually after this. You heard the UC talking about the dinner. So actually it is even worse than he told. So this is how it started, right? We came in, so after that event, we went an hour and a half in a taxi, and out of a sudden UC was asking, hey, how far do we need to go? And the taxi driver said, oh, it's only 2.3 miles. And then I was watching his Waze, and it took 35 minutes to drive 2.3 miles. Right? I said, well, I think we can better walk here. But it's, so UC was a bit disappointed because he was scared that we came late, because Nick was already there. So this is that the people came in. So, and UC actually invited 2 more people, so, but he made the reservation for 6. And then Stephen came in. And Stephen, actually I put your name in red, Stephen, because if this is recorded, then I don't want to get everything punished by Cisco marketing, see you're in an orange number, right? From Aruba. So that's what I did for them. And then this here's where the problem came, right? This is where they said, oh no, don't do this and don't go there, and you have to get out. But I'll ask you, what is the difference you see here? There is 8 people, right? Because that guy also said he's going to join us. And actually there's another one. See the love between Stephen and me here, right? See the love between Cisco and Aruba there. And actually, so imagine what happened. So let's say UC did a perfect negotiation, right? It was amazing. And then, so that we were able to sit with these 7 people on the table. And then Fernie joins. Number 8, right? So I think that would have been really, really painful. And even worse, Fernie went to the restaurant and asked where the group was. And then he came back to us to have that dinner. So, and actually this morning I also figured out, so you remember where Stephen said what he was sleeping when he had a meeting in Amsterdam, because he's living in the middle of nowhere in the Netherlands. So he was sleeping in this big blue kind of hotel, right? So everybody ever been at the Cisco office in Amsterdam? Okay, so the big blue building, now I understand why they win from me, because of the cost saving, right? Because figure out, this is Cisco's building, right? You see the other building next to it, it's the bloody IKEA where he needs to sleep, right? So that's where he is. Now I understand why the cost saving is there. Okay, so let's talk about analytics. And when I did some, I said, I also want to bring analytics a little bit down to where it is. So it's not this magical box on AI and machine learning or deep learning, or give any marketing terminology that you can find out and you probably can attach to analytics. So what I want to do in a couple of pictures is I was figuring out, what if we have analytics and we put it on our movies? That would be interesting. So here is where we start. The first one, anybody knows the movie Taken? Okay, so what happened if this would happen with analytics and Taking? Right? It would ruin the whole movie, because it's searching for an hour and a half for where his wife is or where his daughter is, and then he immediately figures out, right? And this one I'm not going to talk about too much, because I don't want to bring into details in this one. But let's say the Hunger Games. We had, what is it, 5 or 6 Hunger Games? What if you knew when the fog came and where all the people were? That would be really, really boring for us watching the video. And of of course, you always have the dark side, right? So what if we let Microsoft completely figuring out how to do analytics? That would be really strange, right? Do everything in Excel and run this analytics there. That would be bad. So now a little bit more serious. How smart is this analytics actually at the moment? So the first one is here. This is, I think, everybody knew. Remember when the iPhone X or the iPhone 10 came out with the facial recognition? They immediately made a 3D printed face in Vietnam. The cost was around roughly about $150, and they could fake the facial recognition. And that's serious, right? So we need to figure out how serious are we going to take some of this analytics. Of course, a lot of it is in research, but we need to change what we can do and how good is it. This is another one. This is a research being done by MIT. And MIT, so what you see here is guns, right? And they gave this to Google Cloud Vision, where you can do recognition of pictures. And they made tiny changes that human can't see in these pictures, in these guns, and now out of a sudden the gun is recognized as a helicopter. Yeah, that can be a little bit scary. So, anybody know Inspiribot? No? That's an analytics on the web, and you can go there and you can sit there all day. It's amazing how smart it is. So it has these pictures, and you know that you have these pictures saying, oh, your life is the best, or be a team player, blah, 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 blah. This kind of things, right? And they create this. So Inspiribot has the intelligence to create these kind of pictures with these quotes or sayings on it. And they are amazing. You see this one? Think positive, aim for the stars, and do it again and again. It doesn't say anything to me. This one is even better. Seconds are just insects coming to suck your blood. So this is AI we're talking about, right? They say this is an AI project. Then, see this one. After time itself comes the living dead. It doesn't say anything, right? So, but it's amazing. So, then, this is another project is where, you know, that we are pushing so much on self-driving and put artificial intelligence in there. And here you can see some stop signs or, you know, a sign around the corner. And again, they make tweaks in the picture. But figure out, right? Think about it. Let's say you have the possibility to tweak that traffic sign really outside. They make this tweak, and then the car thought it was a 45 limit sign. So imagine people do that in real life, right? So you do self-driving, it is a stop sign, and the car starts to think it's a 45 limit sign. So it keeps on going at 45 miles per hour, for example. And this is really serious. And then this is how I feel always when I'm in this community, right? This is a saying specifically for me if you start to talk about all these RF knobs and bolts, right? Whenever you're feeling stupid, remember to break down and cry. I will spare you and not do that. But let's move into the presentation and let's get serious. So why are we doing analytics? And why are we looking at assurance in here? This is the reason is that if you have to believe Gartner is saying that by 2020, we will roughly have 20.6 or 8 billion IoT kind of devices on the networking infrastructure. So remember, at that particular time, we roughly are with 7.6 or 7.8 billion people on the planet. So almost everything we know of is able to send or receive data in some form. Maybe not all wireless, maybe wired, but it is sent to receive all data in some form. So we got this whole trend of adding devices in our networking infrastructure. And I truly believe there is no such thing anymore in organizations to do SLAs. I think IT organizations are now being judged by experience, right? It's the expectation of the user, or the expectation of the BU, for example, real estate, to add a sensor to your networking infrastructure. And if it doesn't work, then that experience is bad, right? So I think we really need to start judging IT by experience. But this is also getting the problem, because if my application is slow or my performance is not correct, I immediately start to complain. And that's why I also have a new rule. And let's see if we can start to use this each other. Forget MTBF. Forget MTTR, right? We only talk about MTTI. That's we as network administrators, our mean time to innocence. So how quickly can we prove that we are not the bloody problem all the times, right? So that's mean time to innocence for me. Then the next one is if we think about this experience, and this becomes more and more important, I think all of you, with the customers you'll be working, you get this, right? You need to add a sensor, you need to add this and that on the networking infrastructure. If that becomes so key, what is the legacy tools? So current legacy tools, even from Aruba or Cisco, most of the times we are focusing on availability. On availability, monitoring, availability of devices, see some logging in there. But there is not so much visibility to us from a client perspective or from the user perspective, right? How they are experiencing the networking infrastructure. And then the last one is most IT organizations, I don't see an increase in budget or an increase in personnel. Most of the times I say, oh, you do the same, but the only thing you need to do is you need to do a little bit more for the next coming year. That's the fiscal 19 discussion, right? So that's why you need to see is that IT organizations start to see, okay, are there any tools or is there any trends that can give us a little bit more, maybe less off-site visits if you have to do more branches, or maybe figuring out if there is intelligence that can do a little bit better proactive troubleshooting. So that's where we see, and then we did a survey around this, and this is not just only networking, but 57% of all the problems seen in an organization is detected by the user and not by the IT organization. So I think any of the percentage that we can get this down is already perfect for us, right? It's already make sure that we do something from a better experience for the users that we are serving as an IT organization. So this is where Aruba came up with a solution that we called the Aruba Analytic solution. And I know this is, I'm presenting this from Aruba slides, I'm presenting this, and multiple vendors are doing this and looking into analytics. The only thing is I'm beaten to death by Aruba, so that's the only way I can talk. But if I talk about the analytics and the examples, I think you get the idea on what this analytics can be done. This is our solution. We started with everything in orange in the middle. For the ones that have been working with us is that this was Clarity or Clarity Synthetic. This was actually our first step into how can we start doing synthetic testing in networking infrastructure. And this was done from the AP. So some try to use a perspective testing, but not at all, right? Because you couldn't do application testing. There was no way to do proactively run tests for more proactive maintenance or proactive visibility. So that's what's renamed now in Connectivity Health, and that's still there either from the cloud or from an on-prem solution, so that's still there. But that's why we said, okay, we need to scale this out because we need to get more visibility on the user and more from the complete network perspective. From the user is where we have Cape Networks. That's been done in acquisition. I will show you more later. But Cape Networks is able to give us all the testing, application testing, and etc. that you can do from a client perspective. And that's what you want to do. You want to do these testings right at the end of the user, and also more or less a little bit at the space where a user is sitting at his desk instead of high up from the nexus point. So that's what Cape Network does, all this application. So really assurance and analytics from a client perspective. And then on the other hand, we have Net Insight. So I always see Cape Networks from more or less the outside in, right? Client users from the outside in. And then you have Net Insight is where you do analytics from everything else, right? Where you can do verify performance issues, verify client behavior, for example, verify network behavior, misconfiguration. That's what is Net Insight. So for the first part of the presentation, I'm going to focus on Net Insight. And if I'm on time, I want to go into some of the slides and then do a demo of Cape Network so you have an idea what the product also looks like and what you can see. So let's focus on Net Insight first. The first step, what we are focusing on is if you do machine learning, and this counts for any machine learning in the industry, is we need to make sure you do anomaly detection, right? You need to make sure you can do identification, but also prevention of performance issues. That's where we initially were focusing on. And then you need to do Wi-Fi benchmarking. And I think you all had a lot of discussions about Wi-Fi and about benchmarking. But what I mean with this is, and I will dive into this later, is that we really need to start figuring out is how our APs are being used, and is every AP configured in the most optimized configuration, or are we just taking some default configurations, right? So that's, we will dive in later a little bit more. And then the last one of is impact validation. So when we started actually Net Insight and we're doing our initial betas, is that all the network administrators, in particular the Wi-Fi, said, no, it's nice that you see this, but we're not going to change this. You don't give me any proof in what the impact validation will be. So that's why you see impact validation there, because this is your setting before, and this is what you need to do after, and this is what will changing, right? And also it will measure if the change you made really made sense. And I give you a lot of examples where it definitely made sense. And then the last one is give you user insight in order to give you visibilities on this one. This is a machine learning system. We have roughly at the moment around 200,000 access points running in our cloud. We have roughly about 5 million clients in there. And what this system is more or less you have the cloud where you do all the intelligence. And then on the other side is how the user consumes this application is via a dashboard that gives you root cause analysis, and it gives you, shows you all, the ideas what you can do to change this. And of course we want to close loop the system, but I will show you also some roadmap, I think, how we can do this in networking infrastructures further. On the other side, you have the data points, and this is key. You need to get high quality, but also you need to get high quantity of data. And everybody, I think that at any statistics on this is understanding that you need this high quantity of data in order to make sure you're not learning the system something that is not real, right? So we get loggings from our system, from applications in there, from DHCP servers. So that's where we extract the data, and then we compress it and secure it more or less, send it in the cloud, and the user consumes it. So that's roughly what this cloud system is. But these are the customers we tested it out, and they were scared to work with us. And the bigger ones is University of Washington and Ohio State University. They have a lot of access points. But the key factor here is when we started this, and this is the way machine learning is working, is we started with environments that have between 3,000 and 15,000 APs. That's how we started it. And then you can educate the system, you can learn the system. And our education and machine learning algorithms are being built with data scientists and Wi-Fi specialists, because they need to work together in order to figure out what they see and to make proper changes. So this is not that everything goes automatically. This is really a learning phase where you're in. Now, we already are at proof of concept from 1,000 APs or 500 APs environments. So most of these have between 100 and 300 buildings. Now we already bring it back to, let's say, 50 or 60 buildings, right? So you see that the system is starting to learn, and then you can bring it slowly back because you start to recognize things sooner. So this is some of the customers. This is the train of machine learning algorithms. So this is where we are right now. This is where we are within maybe a couple of months, and this is where we are, where we hope to be ever. So where we hope to going. So the thing is where we are right now. The first thing is how could we ensure that we had the right quality and quantity of data. So we have all this clustering and regressions and all this machine learning techniques and anomaly detection to make sure that everything we see is real, right? That we know that we have good and quality of data, and that's key in order to jump into conclusion. And then what we can do with the data, currently we're focusing on a couple of areas there. That's RF optimization, that is a little bit on some device and client behavior, so that's what we will see during the rest of the presentation. Then where we want to go to is we want to go to closed loop control. The reason why we want to go to closed loop control is that you can even say, if you see this, that you automatically, you get this self-driving kind of networking infrastructure where you can fix things before you see them, or you can make tweaks before you see them. And then the last one is the green AP, by the way, is something we did at all the Atmosphere events. And if you have all this data of access points in your cloud, then if you take station models, and you can do time versus distance, for example, you can pretty decent figure out how many APs are being used in your infrastructure. And most of the times AP are being used for worst case, right? So always highest scalability, but they're not always used for worst case scenarios in production environments. So with these station models, we can start turning off features. We can even turn off APs, where we do some green environment inside environments and do some power savings there. So that's what we can do with machine learning in order to figure out on this system. Then the last one is where we want to go to is more telemetry data, see what we can do in combination, for example, with third-party data, etc., etc. So this will be an extension, but that also takes time because you need to get these algorithms really working well. So, what are we going to show? RF config optimizations, device analytics interoperability, performance, and some connectivity issues. And I'm not going to, I have tons of examples actually, but I just try to pick out a few where analytics, I think, where you see the power of analytics kicking in infrastructures. This is one, and this is something that I think Stephen mentioned. I think some of the presentations you have seen this. What we saw is that Wi-Fi not being benchmarked good enough. So what we see here is that what you have is you have around, 100 parameters where you can tweak a Wi-Fi system, or you can tweak a Wi-Fi or RF parameters. You have situations where you maybe have different firmware, or you maybe have old configs. Most of the times what we saw in all these 2000 APs is that they were using a default Aruba config. And to be honest, that default config is nice, but it's a config in the middle, right? It's like a robust config, it's safe, but it's not optimized for every environment. So if you have an environment where you have like multiple lobbies or auditoriums or cafeterias, or where you need to do high density like stadiums, these need different parameters, right? You need to understand what you need to configure. So what we do here is we profile, we get all this data and we can profile all these access points, and then we can compare access points to each other from peers, from different organizations, for example, and we know how they are performing. So if you have an access point that is performing for an auditorium, for example, you maybe need different settings than an access point that is auditorium for maybe in the hallway or something like that. And most of the times we saw there was two different, if you are really brave, is there 2 or 3 different kind of access points configuration, and everything is putting underneath that access point configuration. And even worse, we also saw, for example, why the access point configuration for a 2x2 11N, and then they do upgrades and upgrades and upgrades, more or less keep the same configuration even when access points are getting renewed. So, and they have a 4x4 maybe, right? So these are different things and different benchmarking. If you have a lot of access points, that's hard to figure out. And this is how we do the benchmarking, and we give optimization. If for that particular answer, that's a high density, you can better change this. That's what we can do with machine learning and analytics in these infrastructures. So that's one. Then how is that working? So this is more or less a machine learning train. So here you have the parameters that give you the input. In the middle one, you have the algorithm, and then you hope to have some desired outcome. So what we look at is we look, for example, at these infrastructure features. And stupid thing is, you see AOS version, that's our version, but if you have Cisco, there will be their version for the access point. But even that makes impact, right? Because version by version, we make changes, Cisco make changes, Ruckus make changes, and these changes are maybe good or maybe not for your infrastructure. So you better can, if you have something that uses that information, that can also say, hey, maybe there you can better use that AOS version because that makes sense. Then you have AP models, because a 2x2 is different than a 4x4 and coming 8x8 AX, for example, so that's different settings. And then you got these clients coming in, because clients are also key in an infrastructure that you can use in your machine learning algorithm. So you have your mobility capabilities, applications, so you take all these parameters in, and then actually the last one is where we have control over. That's RF configuration. So all these configurations are coming in. So we know when something is working in what situation or when not. So this is coming in, and this is where we can tweak, right? What is the bandwidth? What is the number of channels, right? Is it 40, 20, 40, 80, whatever thing, the bandwidth size in there. So this is all the parameters that we can control coming in the infrastructure. And then we have this machine learning algorithm come to do something smart with it, doing all this benchmarking, and then if you have a new site coming in, the new site comes in the infrastructure, then you can benchmark that against the data that is in there. And that's what you see, more or less a desired outcome where you can start to do. And then you get the impact validation, figuring out what you need to do and tweak this system. So some of these stuff, for example, is this one. Who enabled DFS in their environment? Okay, so that's pretty decent amount. So when we attach an infrastructure, this is what we saw a lot of times in some of the US universities, is when we also get all the client data in there. So a lot of times DFS is not enabled because they are scared, or they are scared to have clients that is not able to be DFS capable or whatever. So we have all the clients, and we can quickly, do clustering of OUIs and get all the macros in there and do some smart things. So we know also how many clients are maybe in there potentially that doesn't support DFS. So roughly in the database, there is, so everything here in red is like the 2.4 gigahertz band. Everything in blue is the 5 gigahertz. And see that everything in the middle, so roughly about 2/3 of your bandwidth more or less, is not being used with DFS enabled. So after the clustering, so what we saw is roughly 2% of all these 5 million clients do not DFS capable. So for 2%, we create that situation. And that's strange, right? Because we are not using that bandwidth. So with this, we get that machine learning gave that visibility, was able to make it visible for the infrastructure. And maybe if it is 20%, maybe this doesn't make sense. You still need to turn off DFF if that makes sense. But in this situation, for 2%, it doesn't make sense to do this, right? It's a little bit of waste of bandwidth. So that's what we get out of this one, for example, from an RF optimization perspective. This is also an interesting one. This is the University of Washington. And what you see here is like a map of their buildings, and that's where all the students sleep. So that's the dorms, more or less, where they are sleeping. And then you have the more or less the walking ways how students are transferring. What you see here is outside people connected to an inside AP. So what the system was seeing in this environment is they saw a lot of APs running at their max. And you all know if it runs at their max, the next client that comes on is not able to connect, right? So here, as you see all these clients, and what we were figuring out is that a lot of these students were walking to the classrooms, and then all the APs that were in the corner or in the edge of the building, they were connected to it and then stay connected to that particular system, where the indoor users had a lot of issues, right? Because they couldn't connect, or they had a lot of delay, or whatever was going on further. So then we looked at that data and figured out, okay, can we learn the system to do something smarter with it? And we figured out an algorithm where we could detect if the user is either outside or inside. And for this one was for 70,000 students. Every minute we were detecting if it was inside or outside based on the algorithm. So every minute we knew if it was inside or outside. And then you get this dot, right, on this platform. So by the way, this dot you don't see, but it's more to visualize the algorithm of machine learning. And then we could change some of the parameters on the access points by maybe, instead of 0, the local probe, maybe put it on 15 or put it on 25, and then these outside users were not able to connect to inside APs. And that saves them a lot of capacity and a lot of frustration actually at inside users. When we were doing that, we were figuring out, okay, can we do more with this data? And this is the next one, is this one. What you see here is more or less the same picture. Everything in the purple one is sea level. And then if you move up to the green one, becomes more important. So what you see here is how people are moving through the campus. And all the orange squares is an outdoor AP. So what you see here is that not all the outdoor APs are very well designed, right? Because you see some, and actually these are where the students sleep, and then they move here to that area is where they have to go to school, right? They have to go to get the lectures or lessons. So what you see here is that you can immediately figure out is, and all these pictures on here are outside people connected to an inside AP. So otherwise they have not been on this drawing, right? Not been on this drawing. So now you could figure out, it's okay, hey, maybe you can change these parameters better there, or you can do better outdoor AP planning there so that people connect to an outdoor instead of an indoor AP. So this way you could figure out. And then there was somebody in the university, if you have all this data, they want to see if they can use this data, for example, also for 911 or emergency kind of purposes, because you know exactly how people are flowing and moving. So you can use that data for more, but that's not, by the way, in the system, so don't get that. But that's why you see, what you get this data and you try to understand it and try to figure out how you can solve it, you can start to do more with it from an analytics perspective. This is another funny one. So every vendor, this is somebody that bought 10,000 APs. And this is what they bought. Our model is AP335. It's more like a higher end model, but every vendor has a model that is higher end, but you need to get a certain power level to use all the functionality. So for this one, you really need like AT power instead of AF in order to get all the full functionality. So 7,000 of these APs were running on AF power. So 3,000 were only running on the right power. So meaning, by the default power settings, it drop off to about 11N-ish kind of performance for AC Wave 2 performance. 7,000, and you do a complete new investment, right? So that's what we saw here, is we were able to detect that. And then we were figuring out is like with functionalities like IPI, like or IPM, like Intelligent Power Monitor, you can make this priority, and then you can automatically set a priority by switching off, for example, the USB is something else and still get a much higher performance. So 47,000, we were recognizing them, we did this, and they had about double the capacity, still running on AF power, but double the capacity on their access point. And this is the way you can figure out, if you can start to do this in closed loop, you don't run that for a couple of months, right? Because you have the data and the visibility. This one, so sorry Steven, but I couldn't change this, but this one is another funny one actually, is where we have medical devices and some Cisco voice over IP phone that were not upgraded to a different kind of firmware, and they were requesting about a DHCP every 5 to 6 seconds. So that's roughly, what is it, about 10 to 17,000 requests a day. And then you can see here, you can see the trend. You can see that on some of these devices, and you can see the renewal for about, I think it is about 30 days or something, that you can see the graphs here. So, and then wondering why sometimes the DHCP server may be slow, right? If you have this kind of, and you can't do anything about it, because if they just upgraded the firmware of these Cisco phones, the problem was gone. The medical one, you know, they fixed that in the end. But this is also things you get out if you have got all this DHCP data and all this thing. Another one is this one. And this one is, I think, who has an Apple TV? Okay, so an Apple TV in the beginning, they didn't have turned on time synchronization with NTP. So imagine if you want to do authentication. So these devices did about 50,000 authentication requests per day and all filled. So it's almost like, and then imagine that you are in a university and you have thousands of these things running, right? So that's almost like your own denial of service to your own authentication server. And then you also have things like Nintendos and all these things that are on there that are being brought into these organizations. So with the data, you can figure that out and immediately either detect it or close loop later on for fixing it. That's what you can do with analytics from a networking perspective. We have more examples, but I just wanted to highlight a couple of that you see it more from a device perspective, from a capabilities perspective, from an RF optimization. So you went what you can do with all this data to do smart things with it. Then let's focus on user analytics. And user analytics is everything. How can we, more or less visualize a user and dictate or determine what the experience of the user is? And that's what we do with Cape Networks. The thing with these kinds of solutions is that they need to be simple. If you need to deploy these devices, they can't be complicated. Then the other thing is they need to be proactive, right? They need to start continuous tests on their own and figuring out what is really on the network. And they need to be agnostics, because Aruba is not the only Wi-Fi vendor in the world, and there are so many different vendors that are, or maybe organizations doing dual vendors, so you need to figuring out how you can be agnostic in this kind of environment. So we had a company called Cape, and Cape was based in South Africa, and we did an acquisition with them in March 2018. And Cape, what Cape did really well is they created a sensor that could do synthetic testing for clients. So really log into a SharePoint or really do a Dropbox test, download a file, so you get really this kind of analytics and see how the network is performing or how the client is experiencing the infrastructure. And there is external testing, and it is developed with software as a service more or less in mind, but you can also do internal testing, and you can do wired and wireless testing. And what they create up is a sensor. And the sensor has a 3G, the initial one 3G, the new one 4G connection. So you can just ship it anywhere and it will find its way with 4G to your cloud system. That is very, very convenient from a deployment perspective. Then you can configure it, you can connect it to an SSID, and you can start all these tests. You can group them to make configuration easier, etc. Then you have the dashboard, and the dashboard is really, really cool. So that's why I will go very, very quickly to some of these slides, because I want to show you the product in order to, I think it is better if you see the product. Then this one, let me move to one slide that I want to show you, is that this one. Is this one I want to show you, because if you have a CAPE sensor, imagine that you have that 4G in there. So if you have it running on a remote location, you also want to make use of that, right? So if you need to do, these are super caps on there. So if the power fails, it has about 40 to 45 seconds power. And what it does in the meanwhile is scan that environment for other beacons and does a couple of tests. And then the last couple of seconds it uses to upload that data via 4G to the cloud. So then you always know if in that branch is a power down or you have a networking issue. And that is really convenient. You can also use that sensor to remotely connect with the Wi-Fi Explorer tool, where you can remotely connect it and start using it as a sensor for remote troubleshooting, for example. So that's very convenient if you have it for remote branches. So let me show the dashboard. So who has children in this room? And which children do gaming? And which one do Fortnite or something like that? Ah, there we go. Man, you want to have this too. Believe me. I have 3 boys. And, well, that's it actually. So see what I am measuring. That's my mean time to innocence against my children, right? These are all the Fortnite servers running in Amazon. And damn right, if they complain, actually one of them most of the time is in a bad color. So they are, the only thing that happens, they are earlier dead than anybody else. So it doesn't matter that much, but for them that's a big deal. So this is the dashboard. So you can see the traffic light, where you go more or less from your experience of your whole infrastructure to the Wi-Fi settings, to network settings, to internal and external testing. So very, very, very simple way in setup. But this is also designed for more network administrators. So if you click on this, you can see much more data about some of the, and you can click further and you can see some of the latency or some of the settings in here. And then you can go deeper and deeper into this messaging to figuring out what the real problem is in that environment. So the way you can set up tests, if you go here, you can see my sensor, and then you go testing. You can see I have set up some tests. Here you have Facebook test, Salesforce test, but you can also do Dropbox. I can add one. So let's say I do an external one, and you can see all these tests being in there, but where you really do, and actually I made one mistake because I moved in the Netherlands, I moved from one house to the other, and I had broadband, and I went to non-broadband. Actually, you don't make yourself more popular at your children if you do that, actually. But so now I have 2 things. I said, no, don't worry, I said to them, because we wanted to move to that house. So I said, we have ADSL, but I was around, I think about 350 meters away from the closest ADSL. So that means 6 megabit per second is a lot, actually. That's a lot if I make that. So now I went to 4G, but 4G is also very unstable. But now I do load balancing over it, so it goes better. But what happened here is that I put a test on, Netflix test, and I did that to show it in a customer demo, but I did that every 3 seconds. And what I didn't was aware of that I was downloading. So out of a moment I was connecting to the controller and saying, the sensor is the biggest client you have, and it used in the last 3 hours 60 gigabit. I said, man, and then if you have 4G, and so 6 megabits of ADSL, and 20 at max, more or less 4G, then you don't make yourself even more popular, right, in that environment. So this is how you can set up a test. So you can, let me take one, for example, LinkedIn, where you can really test the LinkedIn experience. So let me If you go there, you can add SSIDs, you can add multiple SSIDs, whatever you want to do. You can connect that to groups. It is really, really simple. You can set thresholds. And thresholds we have like, there is like a availability threshold. So this way you can start collecting data and do something really with the data. So I'm not going too much details, but if you go here to external, oh, sorry. Let me click one of the tests, for example. And you can see here is also a way you can start see what is happening in that moment in time if there has been an issue. What it also does, it has a container of packet capture. So if you got a real serious error, it always contains that packet capture, attach that packet capture to an error. So this way, you can start using all these analytics, high-level view of how it is experiencing, get deeper dive if something is wrong with all the detailed information. I don't want to go deeper because I don't want to give a full-blown CAPE session here, but you can start to imagine what kind of you can do and start really measuring this infrastructure with analytics. So let me then move back here because I think I'm almost done on time here. So this is an example of the US Open that started to use. The only reason why they wanted to do this is they didn't want to bring their IT administrators on site anymore, want to do more clever things with these solutions from a more remote. So that's how they started with 4 and then they ended with 80 of these sensors to keep continuous measuring how your guest experience was on the infrastructure. Yeah, and then do something smart with the Linux, come to conclusion. So then I want to close off with one more thing. Right, you remember that InspiriBot? I have a couple of ones for you to close it off. Don't make art, just do the impossible. That's another one, right? It's amazing. And then this one. After the impossible comes as beautiful as a lie. So I hope you don't think that everything I said is a lie here. Actually, that's the truth. But let's see how I don't believe you there. So thank you very much. I hope you liked it. And if there's any questions, and I think we can take it later on. And I hope I'm on time.
Yeah, you are.
Oh, man, that's amazing. Thank you.